All right, hello, it's Mrs. Griswold here, and we are on Unit 9B, Day 2. We're going to learn how to solve quadratic equations using square roots. All right, our first part of our learning target is learning how to simplify square roots. And then the next part of our learning target is to solve quadratic equations using square roots. Okay, so to get our brains thinking, basically for what we want to do today is I'm going to throw this warm up out there. Okay, I know you're kind of like, well, this is random. What does this have to do with anything? It's going to help us get ready for what we're going to do later. All right, so solve for 3x minus 2 equals 16. I want you to solve for x. All right, so hopefully you paused and you solved for x. Okay, if I want to get x all by itself, remember I do reverse PEMDAS, which is the order of operations. Okay, so I look to see if there's anything that I can add or subtract away. Well, I've got minus 2, so I'm going to add 2 so that that goes away. I'm going to add it to both sides. Okay, now over here on the left, I've got 3x left, and on the right, 16 plus 2 is going to give me 18. Okay, now I like to see if there's anything that I can multiply or divide. Well, 3 is being multiplied by x, so I want to divide by 3 to cancel those out. And then I get x equals 6. All right, so we're going to be doing something very similar today, except for this one is a linear equation, because it's just x to the first power, and we're going to be doing this with quadratic equations. So it's really important that we know that basic skill of solving a two-step or a multi-step equation. All right. So one thing I want to talk about first that's going to help us for today, kind of moving on tomorrow, what we're going to talk about are perfect squares. So if you remember, perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16, okay, and so forth. All right, perfect squares are these. These are the perfect squares. Okay, so 1, 4, 9, 16, and so forth. And the other thing that is really cool about perfect squares is that when we take the square root of them, they are whole numbers. So square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 25 is 5, and so forth, on and on. All right? Because it's so important that we know these perfect squares and their square roots, I would say that you should have from 1 to 100 perfect squares memorized. So if I ask you, what's the square root of 36? You should know off the top of your head that that's 6. Okay? Not just for this class, but you're going to need that in geometry. You're going to need that in Algebra 2 or Advanced Algebra when you're a junior. If you keep going on to more math, you're going to need to know these. So it's really important you practice those now. Pull out those note cards. We will have questions on the homework that will have you practice these as well, which will be good. Okay? All right, so the first skill that we need to do in order to solve using square roots is we need to know how to simplify square roots. So sometimes we're going to run into a situation where we want to find the square root of a number that's not a perfect square. So our first example is the square root of 12. Well, I know that 12 is not a perfect square, and if I typed the square root of 12 into my calculator, it would give me a decimal. All right? Now that we're in high school and we're in high school math, we aren't going to type this into our calculator and get a decimal. We're going to simplify it using square roots. Okay? So I'm looking at the number 12. In order to simplify this, I want to find the largest perfect square from my list. So I have them listed right here so that we can see them. These are all my perfect squares. The largest perfect square that divides evenly into 12. Okay? 12 isn't too bad because it's a smaller number, so we can kind of find that quickly. But what some people want to do when they're looking through this is they want to start with the number 1 and then work their way up until they find the first perfect square that divides into 12. But we're going to say do the opposite, because if you go from the smallest perfect square to the largest perfect square, you might not find the largest perfect square that goes in. So when we're hunting for the largest perfect square, we want to go largest to smallest. Okay? With 12, it's kind of easy to spot that 4 is the largest perfect square that divides evenly into 12. Okay? So what we do is we take that perfect square, and now we rewrite it with the not perfect square that it multiplies by to get me 12. So 4 is my perfect square. 4 times what gets me 12? Well, 4 times 3 gets me 12. It's important that I'm writing both of these under the square root because 12 is under a square root. So both of these numbers have to be under the square root. Okay? So I've got my perfect square, which is 4, and my non-perfect square, which is 3. The reason why I looked for a perfect square is because I can evaluate that. So the square root of 4 is 2. And the square root of 3 can't simplify any further, so I'm going to leave it square root of 3. Now this 2 square root of 3 is rewriting the square root of 12 in exact form. Okay, so if you type in square root of 3, it's going to give you decimal. It's going to kind of repeat. So 2 square root of 3 is the exact form of that decimal. Or sorry, yeah, I guess is the exact one. Okay, so 12 is a little bit smaller. Let's try a bigger one. I've got square root of 32. Okay, so I want to look from the largest perfect squares to the smallest perfect square. Okay, I'll give you a hint, is we don't really want to look at any numbers that are bigger than 32 because we know that those aren't going to divide evenly into 32. So we can start looking at the next perfect square that's smaller than 32, and that's 25. Okay, does 25 go into 32? Well, you can check by doing 32 divided by 25 in your calculator. Well, I get 1.28, and that's not a whole number, so 25 does not go into 32. Okay, then I go down to my next one. Does 16 go into 32? Well, 32 divided by 16 is 2. So that means 16 is my perfect square, the largest perfect square that divides evenly into 32. So I'm going to split 32 into its perfect square, which is square root of 16, and its not perfect square that 16 multiplies by to get 32. So 16 times 2 is 32. All right, so I find the largest perfect square, and then I kind of break it apart into those two pieces. And remember, I specifically chose the square root of 16 because I know the square root of 16 is 4. And then the square root of 2, I can't simplify any further, so that's just going to stay square root of 2. And now I have rewritten that perfect square in simplest form. All right, and we can check in our calculator, and I can show you that square root of 32 and 4 square root of 2 are the same thing. Okay, so square root of 32 is this decimal that's going to continue on, and then 4 square root of 2, look, it's the exact same decimal. Okay, what you get in your final answer should be the exact same as the first one. It's just written in a more simplified form. Okay. All right, let's try a couple more. We want to start off by looking for the largest perfect square that goes into that number. When I look at my list of perfect squares, I'm not going to look at anything bigger than 18 because I know that that's not going to divide into 18. So the next perfect square that's smaller than 18 is 16. So let's see. Does 16 go into 18? No, 16 doesn't go into 18. It gives me a decimal when I type into my calculator. All right, then the next largest perfect square is 9. Does 9 go into 18? And I test it. Yes, it does. 9 goes into 18 2 times. So I split 18 into my perfect square, square root of 9, times the other number that multiplies by 9 to give me 18. Okay, so square root of 9 times square root of 2. And I specifically did that because the square root of 9 is 3. And then I leave the square root of 2 because I can't simplify that any further. All right. You try this next one, simplifying the square root of 24. Go ahead and pause this video right here and then simplify. All right, so the largest perfect square that goes into 24, well, we start with looking at 16. Does 16 go into 24? No. Does 9 go into 24? No. Does 4 go into 24? Yes, 4 does go into 24. So 4 is going to be my perfect square. 4 times what gets me 24? Well, 4 times 6 is 24, so that's my non-perfect square. The square root of 4 is 2. I specifically chose that because I know it would be a whole number. And then I leave the square root of 6 because I cannot evaluate that any further. So square root of 24 simplifies to 2 root 6. All right, and then lastly, square root of 45. Remember, I'm going to look through all of these perfect squares, starting from largest going to smallest. Remember, I don't want to look at anything bigger than 45, so I'll start with looking at 36. Does 36 go into 45? Well, no, it doesn't. That gives me a decimal. Does 25 go into 45? No, that gives me a decimal. Does 16 go into 45? Nope, that gives me a decimal. Does 9 go into 45? Yep, it does. Okay, if you know these factors off the top of your head, you don't necessarily have to work through all of them, but I think it is good when you're starting to make sure you start with the largest perfect squares and work your way down. Otherwise, we won't get it fully simplified. Okay? All right, so square root of 9 times square root of 5 is 45, and I know that the square root of 9 is 3. So square root of 45 written in fullest, simplest form is 3 square root of 5. All right, that's our first part of our learning target. It's important that we know how to do those. Okay, now let's get into solving quadratics using square roots. All right, quick review question. How many solutions can a quadratic have? We can have 0, 1, or 2. Remember, we can have 2 solutions. So when we're solving using square roots, we should almost always have 2 solutions. Okay? All right, so we're going to use something called the square root property to solve quadratic equations in the form, and this is key, is recognizing the form when to use the square root property. So the 2 situations and when we use the square root property is when I have x squared by itself. So there's no bx term, and I have that over here, but I'll put that in the middle. Right? If I have x squared plus bx something else, right, standard form, then I cannot use square roots and I have to graph or factor or use the quadratic formula, which we haven't done yet, but we'll see those in the next couple days. All right, the other thing that we see when we use the square root property is quantity squared. So when I see parentheses squared, which you know comes from vertex form, that gives me an idea that I'm going to be using my square root property. Okay, there are a lot of different quadratics and there are 4 different ways that we can solve, so it's really important that you recognize these tiny details because they'll give you guidance on how we want to solve. Okay, so just like how we solved that linear equation, we need to use opposite operations. So we know that plus and minus, those are opposite operations, right? They'll undo each other. Same thing with multiplication and division. Those will undo each other, right? If I have 3x, I divide by 3, right? Opposite operations. Okay, one thing that you might not be the most familiar with is x squared and square root are opposite operations. So if I have x squared and I take the square root of that, those cancel, leaving me with x all by itself. Okay, so they are opposite operations. They cancel each other out. So let's get into our first example. Now this is just going to be a bunch of examples because we're going to see things written a lot of different ways, but the more practice, I think, the more we can recognize and then be able to solve on our own. Okay? So this time, instead of just the square root of something, right, that I need to simplify, I have x squared equals 36. And the directions say, solve the following quadratic equation for all values of x in simplest form. So that means our square root should be in simplest form. Okay? So in order to get x squared by itself, I have to do the opposite operation, which is the square root. Now the square root and the square will cancel, leaving me with just x. But remember, like solving linear equations, what I do to one side, I have to do to the other side. Okay, so I take the square root of one side and I take the square root of the other side. Now, before I write my answer, actually, no, I'll write it. I'm going to leave a space though. Okay, it's not just 6. All right, and I'm going to use my calculator to demonstrate this. Yes, the square root of 36 is 6, but my solution is not just 6, okay? And here's why. I want values of x that make this true. So x squared equals 36. I know that 6 squared equals 36, but what about negative 6 quantity squared? Okay, if we do that in our calculator, we can see, if we have parentheses, negative 6 quantity squared, well, that's 36 as well. Both 6 and negative 6 squared are positive 36. So both of these values for x would work to get me x squared equals 36. So my solution is not just 6. What we do is we add a plus, we call it plus or minus. So it's kind of two values in one, basically. It's negative 6 and positive 6. Instead of writing the same number twice with different signs, we just do plus or minus, and that way it kind of takes care of it. So whenever you take the square root of both sides, like we just did, right, we took the square root of both sides, we have to have the plus or minus. There are two values that are solutions. If we think about the graph, we're pretty familiar with graphs. If we think about the graph, this is positive 6 and this is negative 6. My parabola, however wide or skinny, will cross the x-axis in those two spots. So that's why we have 2. Okay, let's kick it up a notch. This time I've got x squared minus 3 equals 22. Okay, I want to solve for x, so I'm going to follow the exact same process that we did when we did a linear function. I want to get x squared by itself. Just like in a linear function, I wanted to get x by itself, I want to get x squared by itself. So the first thing I have to do is I have to add 3 to both sides. And I know a lot of you like to do that line. We'll do that line. Okay? So those will cancel, which means I have x squared, 22 plus 3 is 25. Now this looks just like the one we just did. In order to solve for x, I need to take the square root of both sides. The square root and the squared will cancel, leaving me with just x. But remember, the square root of 25 is not just 5. It's positive 5 and negative 5, right? Because 5 squared is 25, and negative 5 squared is also 25, okay? So you could write 5 and negative 5, or you can write x equals plus or minus So it's kind of a more concise way to write my final answer. So if I plug either of those values in for x, I will get 25. Okay? So we're going to continue to build, get a little bit more difficult. So I've got x squared minus 2. Now remember, these have no bx term, right? I've got a and I've got c and I've got something on the other end. They have no bx part in the middle, and that's why I can use square root property. Okay, so just like the last one, I want to get x squared all by itself. So what I do is I'm going to do the opposite operation. I'm going to add 2 to both sides. And I get x squared equals 24. Okay, so just like what I did, get the x squared part by itself. Now that it's by itself, I can take the square root of both sides. All right, this time, okay, I took the square root of both sides, so I'm going to put my plus or minus because I know I have to have that. But the square root of 24 is not a perfect square. And it says that I need to put the values in simplest form, so I cannot leave it square root of 24. I have to think about the largest perfect square that goes into 24. I should have rewritten it. 1, 4, 9. Here, I go that high. Okay. The largest perfect square that goes into 24, well, it's 4. So 4 is my perfect square. What number multiplies by 4 to get me 24? Well, that's 6. So 4 is my perfect square, and 6 is my not perfect square. I split it up so that I can write it in simplest form. I still have my plus or minus. That's really important that I have that as part of my answer. The square root of 4 is 2, and then the square root of 6 is not a whole number, so I just leave it square root of 6. All right, my final answer is x equals plus or minus 2 square root of 6. And you will have that plus or minus button in Delta Math so that you can do it. Okay, I know we've been going for a little while, but we got to keep powering through because these are going to keep getting a little bit more involved as we go through. More and more steps. Okay, kicking it up a notch this time. I want to get the x squared part all by itself. Now there's a little bit more that I have to do. Now it's like a two-step equation. So I do my reverse PEMDAS. So I first look to see if there's anything I can add or subtract away. And there is. There's 16. So I'm going to do the opposite operation and subtract 16 from both sides. Okay? Now I know that those cancel out, so what I have left over here is negative 3x squared, and that's equal to negative 3. Okay? Again, I'm still trying to get this x squared part all by itself before I do anything else. So I'm going to divide by negative 3 on both sides, and I get x squared is equal to positive 1. So negative 3 divided by negative 3 is positive 1. Okay? Now I'm at the point where I have my x squared all by itself, and now I can take the square root of both sides. As soon as I take the square root of both sides, I know I got to have that plus or minus. So I'm going to put that in right away. Okay? And then the square root of 1 is 1. So my answer for this one is x equals plus or minus 1. Okay, and remember, that is positive 1 and negative 1. Those are two numbers. My graph would go through both of those x's if I were to plot it. Well, actually, this one would be concave down. My bad. But still, you get the idea. Okay, notice that one had a couple more steps before I could take the square root. Let's keep building, make it a little bit more difficult. Like I said, it's just a lot of examples, a lot of practice, okay? I want to get the x squared part by itself. Reverse PEMDAS, is there anything I can add or subtract? Well, there's a positive 10 over here, so I'm going to subtract 10 from both sides. Those will go away, leaving me with negative x squared over there. Negative 27 minus 10 is negative 37. And then x squared isn't quite alone yet, right? I got that negative out in front that I got to deal with. So in order to get rid of it, I can divide by negative 1. And I get x squared equals 37. Okay. Now I think about, are there any perfect squares that go into 37? Okay. Does 36 go into 37? No. Does 25 go into, oh, I guess, sorry. I forgot, we gotta take the square root of both sides. Always have it plus or minus. Okay. Square root of 25, does that go into 37? No. Does 16 go into 37? No. Does 9 go into 37? No. Does 4 go into 37? No, it doesn't. Okay, so 37 cannot be simplified any further than it already is. So that is my fully simplified form, and I just have to leave it as the square root of 37. Okay, do not give me the decimal. I can't simplify it any further, so just got to say square root of 37, and that would be my final answer. And don't forget that it's plus or minus, because both of those will give me 37. Okay? All right, I think this might be the last. Yep, the last one of these where it's just x squared with no bx term, and before I get into quantity squared. All right, stick with me. I know this is a long video. All right, so I want to get x by itself. So I want to do reverse PEMDAS. So first I'm going to subtract 16 from both sides. So that's going to leave me with 2x squared equals 14. I almost wrote 16 again. Yes, 14. Okay. I got 2x squared equals 14. Now I still am not quite there. I want to get that x squared part completely alone. I got to divide by 2 on both sides. And I get x squared equals 7. Once I get the x squared part by itself, I want to take the square root of both sides. And I can write x equals plus or minus, always having that in there. Now I want to see, can I simplify the square root of 7? Well, the closest number that's smaller than 7, the closest perfect square is 4, which doesn't go into 7. And 1 does, but I don't need to simplify that. So the square root of 7, just like the square root of 37, can't be simplified any further, so we have to leave it as the square root of 7. Okay? And again, remember, this is two values, positive square root of 7 and negative square root of 7. Two values. If we think about the square root of 7, we type that decimal into our calculator. The square root of 7 is 2.65. So if we thought about our graph, square root of 7, negative square root of 7, concave up, it would go through, it's so rough, those points. 2 points, 2 solutions. All right, so I know that was a lot of examples. We are almost done. Here's the next part that we will also have to deal with. And I talked about this in the first slide. I said, not only will we have x squared with no bx term, but we'll have quantity squared And we also want to solve these using square root property. Okay, I'll just make a note that this is vertex form. Okay, we should remember that from last unit. Okay, so here is the difference. This first problem, I have x minus 6 in parentheses squared. I cannot add 6 because right now it is currently locked into those parentheses. I cannot add it to both sides, okay? Because I have parentheses squared, I need to get rid of those parentheses first. So we have to get rid of the squared first. So remember, in order to get rid of the squared, we take the square root this time of the whole thing, and those are going to cancel out. And now x minus 6 is free. It's free from those parentheses. But what I do to one side, I have to do to the other. So I also have to take the square root of 25. Now remember, whenever I take the square root of both sides, I have to have my plus and minus. So luckily, the square root of 25 is a perfect square. And the square root of 25 is 5. Okay, so now I have x minus 6 equals plus or minus 5. Well, this is really two equations. And at this point, I'm going to set up two equations. Because plus or minus 5 is two numbers. It's positive 5 and negative 5. I have to set up one equation, x minus 6 equals positive 5. And then another equation, x minus 6 equals negative 5. So it's really two equations that I need to solve, two values for x. Okay? If I start with the first one on the left, I'm going to add 6 to both sides, and I get x equals 11. Okay, that's one of my roots, one of my solutions. And then on the right, I add 6 to both sides, and I get x equals 1. Okay, those are my two solutions. Remember, quadratics have two solutions. So I have two numbers, 11 and 1. If we picture my graph, 1, 11, concave up, it would go through both of those points. Okay, keep trying to relate it back to what we know. Okay, same thing. I've got my quantity squared. That 1 is locked into those parentheses unless I get rid of it. So right away when I see quantity squared, I take the square root. Those will cancel, and now x minus 1 is free. It's free from those parentheses. But what I do to one side, I have to do to the other. So I take the square root of 81. As soon as I take the square root of both sides, I got to have my plus or minus. And the square root of 81 is 9. Luckily, that's a perfect square too. Okay. So again, in this case, I have to set up two equations. One for positive 9, x minus 1 equals 9. And one for negative 9, x minus 1 equals negative 9. Okay, a lot of people are tempted to just do plus 1 and say x equals plus or minus 10. Okay, that is the biggest mistake that I see, because we do this in algebra 2 as well, and that's one of the biggest mistakes that I see, and we cannot do that. We have to set up two equations at this point. Okay, so now I add 1. And one of my solutions is 10. And then on the right, I add 1. Negative 9 plus 1 is negative 8. So one of my solutions is 10, and one of my solutions is negative 8. Okay, kick it up a little bit. I got a little bit more numbers going on here. Okay. I want to get the quantity squared. Okay, now this time it's the quantity squared. I want to get that by itself. But right now it's being multiplied by 2 in the front. So my first step is to divide by 2. So that goes away. I still have x plus 3 quantity squared locked in parentheses. and 18 divided by 2 is 9. Okay, so just one more step before I can get that parentheses squared alone. Now I still have 3 locked in those parentheses, so I have to take the square root of both sides. Those will cancel. Now x plus 3 is free. Square root of 9 is plus or minus 3. Okay, so think about this. Whenever we have vertex form, whenever we have quantity squared, we have to set up 2 equations. X plus 3 equals positive 3, and x plus 3 equals negative 3. Okay, minus 3 from both sides, and I get x equals 0 is one of my solutions. Minus 3 from both sides, and I get x equals negative 6 for my other solution. I still got 2. Okay. I'm going to skip that one, and I'm going to just go to the double duty one. The hardest one probably that you'll see on the homework. And it's one like this. And I think this will be the last one because this video is already, oh, very long. Too long. Okay. So I want to get x squared part all by itself. Okay. So think of it as like 3x plus 47 equals 50. And I want to isolate that x. It's very similar to what we're doing. X plus 4 quantity squared is just like a bigger version of that. So I start by doing reverse PEMDAS, subtracting 47 from each side. So that will go away. Okay. Over here, I still have 3 times x plus 4 quantity squared. 50 minus 47 is going to give me positive 3. Okay. Now, I still am trying to get x plus 4 quantity squared alone. So I got to divide by 3. 3 divided by 3 is 1. So I'm not there yet. Look at those. There were 2 steps before I could get x plus 4 alone. Now that I have it alone, I can take the square root of both sides. Now those will cancel, and I've got x plus 4 is free, and I have plus or minus 1 because the square root of 1 is 1. Set up 2 equations. X plus 4 equals 1, and x plus 4 equals negative 1. Always set up 2 equations. Subtract 4 over here. My first x value is negative 3. 1 minus 4. My second x value, negative 1 minus 4 is negative 5. Okay, so negative 3 and 5. All right, I know that was a long lesson, but I just wanted you to see as many examples as possible, and you should be ready to do the Delta Math assignment.